Okay, Algebra 1, we're moving on to section 5.4. So section 5.4 is on factoring quadratic trinomials. And if you remember, a trinomial has three terms. It's a three-term polynomial, and a quadratic polynomial has an x squared term as the highest power of x. So the degree of a quadratic polynomial is 2. So this is a really important topic, and so I'm calling this a pivotal Algebra 1 topic. So I have a picture of one of our newest saints, John Henry Newman, because he's considered a pivotal player in the Catholic Church, so that's why he's in there. Okay. So we're going to learn how to do the reverse of what we did in the last section. So in the last section, we multiplied binomials together. And so now we're going to start with the multiplied out version, x squared plus 8x plus 15. And we're going to transform it into factored form, x plus 3 times x plus 5. So our answer is going to have parentheses in it. And so this process is called factoring the polynomial. To factor a polynomial means to transform it into a product of two or more factors. So we're going to start very easy with factoring, but it can get pretty tricky, and you're going to continue to factor in every math class you take until you finish calculus. So it's very, very important. So we have to learn it well. Okay, so let's learn how to factor a quadratic trinomial first, and then we'll, which is the easiest kind of factoring, and then we'll move on to factoring more complicated things in later sections and in other chapters. We'll do more. So there are different ways to learn how to factor. I'm going to teach you a way to factor so that you can do a lot of the work in your head and do less writing. I will also show you a longer way to factor, not in this section, but in future sections. And so you could choose to do your problems that way, but I don't recommend it because it takes more time. So we have x squared plus 8x plus 15. So our answer, we know, is x plus 3 and x plus 5. And it's actually not very hard to figure out what goes in our first slots because we know we want to end up with x squared. So we're going to have x in our first slots because when we FOIL it back out, we want it to look like x times x, which is x squared. Okay. Now, that was kind of the first step. So I'm going to number this 1. Now, our second step, we have to look at the 15 and the 8. So, okay, we need 2 factors of 15 whose sum is positive 8. Okay, but what I mean by factors of 15. So let's talk about all the factors of 15. Those are all the numbers that if you take 15 divided by them, you get an even answer out. So that would be like 1, 3, 5, and 15. Those are all the factors of 15. So we need 2 factors of 15 whose sum is 8 and the product is 15. And that's because you want to put those 2 numbers here and here, and then if we were to FOIL this back out to check our answer, then we should get the x squared plus 8x plus 15. So What I will often do to look at the possibilities is I will draw a T-chart. And what I mean by that is I write 15 at the top, the thing I want a product of, and then I'll write possibilities at the bottom, or in a list. So 1 times 15 is 15. Those are two factors of 15. However, if we take 1 plus 15 and we add them together, we get 16. That's not a sum of 8. That's not what I want. Now you can also change the, make 1 and 15 positive or negative or a mixture, but I'll show you that again in a more difficult problem. So let's look at 3 and 5. 3 times 5 is 15, and 3 plus 5 is equal to 8. So what I'm thinking is that I have a 3 and a 5 are going to go in our second slots, our last terms. And since all of the numbers are positive here, I'm going to put plus signs in between the x and the 3 and the x and the 5. Now, if you were to FOIL this back out, you should get x squared plus 8x plus 15. So this is the answer, but now I want to check it. And actually the fastest way there, you could check it like we did in the last section where you let x equal 1 and you plug it in and make sure you get the same answer. Or I usually check x plus 3 times x plus 5 by FOILing. I would take x times x. Those are our first terms, is x squared. Our outer terms would be x times 5. Inner terms would be 3 times x. And last terms would be 3 times 5 is 15. And I get x squared plus 8x plus 15. So I factored correctly. All right, here is an example. So the example is supposed to be x squared plus 7x plus 10. So it's not a negative x squared. All right, so when you're asked to factor something like this, we're starting with 2 sets of parentheses, and we'll leave some space so we can write stuff. So to get x squared, we know it's going to be x times x. Now, we want to figure out, we take our last number, which is a positive 10, and we make a T-chart. And I want to figure out two numbers that multiply to give me 10, that add to give me 7. So pause and see if you can find two numbers that multiply to give you 10, but add to give you 7. Okay, hopefully you got 2 and 5. If you had tried 1 and 10, you would see there's no way to add or subtract 1 and 10 to get 7. So 2 and 5, that's what we need. X plus 2 and x plus 5. And I can FOIL by, I can check my answer by FOILing. F-O-I-L. So the first terms are x squared, the outer terms 5x, the inner terms 2x, and the last terms 2 times 5 is 10, and I get x squared plus 7x plus 10, which was my original question. So I got it right, so that means this is my final factored answer. Okay, example 2, factor x squared plus 9x plus 20. So I start with 2 sets of parentheses. It's pretty easy to see. I'll have an x in first slots. X times x is x squared. But now I want to look at that positive 20. I need to get two numbers that multiply to give me 20, that add to give me 9. So multiply to give you the last term and add to give you that middle coefficient, 9. So that would be 4 and 5. So x plus 4 and x plus 5. Multiplication is commutative. What we're doing here is we're taking x plus 4 and multiplying it by x plus 5. So of course that's the same thing as x plus 5 times x plus 4. It doesn't matter which order you write the parentheses in. And again, we could check our answer by FOILing it back out. Okay, pause and see if you can factor this one on your own. Did you pause? Okay, so we want two numbers that multiply to give us 20 and that add to give us 12. So if you look and you try 4 and 5, there's no way to add or subtract 4 and 5 that will give you 12. Well, 20 has other factors like 10 and 2. And if you take 10 and 2 and add them, you get 12. So you need a 10 and a 2, and we have all pluses, so it's going to be easy. We're going to have pluses inside as well. Okay, and again, you can check your answer by foiling. Moving on. Okay, x squared plus 21x plus 20. So again, we're dealing with a 20. We know we're going to have x's first. X times x is x squared. Now 20. We tried 4 and 5, and that gave us a 9. If we took 4 minus 5, we would get negative 1. If we took 5 minus 4, we get positive 1. But we're looking for a positive 21, so that's not going to be 5 and 4. What about 10 and 2? Well, we'd get 12, or if we did 10 minus 2, that would be 8, or 2 minus 10 is negative 8. That's not going to give us 21. 20 has two other factors. 20 times 1 is 20, and 20 plus 1 is 21, and that's what we want for our middle term. So the final answer is x plus 20 times x plus 1. Okay, now let's start adding in minus signs. So this is going to make this one trickier. We're still dealing with 20. So I want a positive 20. And when you want a positive 20, either both numbers have to be positive to get a product, or both numbers have to be negative, because a negative times a negative is a positive. Since we have a negative here in the sum, that means we're going to have a negative times a negative. So I want to find two numbers, then when I add them up together, I get negative 12, and when I multiply them together, I get positive 20. So pause the video, see if you can find the right answers. Okay, so suppose you tried 4 and 5 first. You would see quickly that negative 4 plus negative 5 is negative 9. That's not going to work. And if we tried 10 and 2 and made them negative, negative 10 plus negative 2, that's negative 12. That's going to work. So when we factor, instead of having x plus, we'll have x minus 10 and x minus 2. Because again, they add to give me negative 12, and they multiply to give me positive 20. All right. So here's our next example of factor x squared plus 15x plus 20. So we've got two sets of parentheses, and we have 20. What two numbers multiply to give us 20 and add to give us 15? So it's going to be two positive numbers. So I'm going to try 4 and 5. Nope, that adds to 9. I'm going to try 10 and 2. That adds to 12. And I'll try 20 and 1, and that adds to 21. There aren't any other pairs that multiply to give me 20. So actually, we cannot factor this polynomial. This is a prime polynomial. Just like we have prime numbers, like the number 7 is prime, it can only be written as a product of 1 and itself. So 7 is prime. We can have prime polynomials, meaning we cannot factor them. So the answer is prime, and that's what we want to write in the box. A prime polynomial is a polynomial whose only factors are 1 and the polynomial itself. And that's it. You're already done with section 4 of chapter 5.